when the F-35 represents the cutting-edge technology of the U.S. aviation industry, demonstrating its prowess globally and easily suppressing Russia's proud S-300-400 air defense systems. It was originally thought that only after the J-35E is exported in large numbers could a balance be achieved through an offensive-counteroffensive approach. However, recently, the U.S. Army recognition website, citing the quantum radar mentioned by the South China Morning Post, has provided a new direction to unilaterally offset the decades of stealth technology accumulation of the F-22A and F-35. The so-called quantum radar is actually a remote detection concept proposed by Professor Lloyd of the Massachusetts Institute of Technology in 2008. Its core idea is to use the quantum properties of photons to detect the position of remote targets in a new way. Simply put, previous radars used electromagnetic wave reflection to determine target positions, while quantum radar uses photons. The basic architecture is similar, but the methods differ. In 2012, after years of research, the Institute of Optics at the University of Rochester built a quantum radar model with extremely strong anti-jamming capabilities, which was regarded as the most important development direction in the field and caused a sensation at the time. However, the US quickly discovered that, at the current technological level, the greatest value of quantum radar lies in subverting traditional radar working mechanisms. Stealth fighters like the F-22A and F-35, which are designed against traditional radars, are naturally greatly affected, even facing catastrophic consequences. Therefore, the US subsequently shifted its follow-up research on quantum radar underground, and there has been no public news for many years. But for China, which had not yet equipped the J-20 at that time, quantum radar was a very attractive direction. In 2016, a domestically produced quantum radar developed by multiple units made its debut and completed detection tests in the outdoor atmosphere, confirming a detection range of over 100 kilometers and a significant improvement in sensitivity compared to traditional radars. The South China Morning Post mentioned in a recent article that China has begun mass-producing mature 4-channel single-photon detectors. This advanced equipment, which can theoretically be called a quantum radar, will detect F-22A and F-35 at longer distances due to the latter's lack of preparation. So far, it's all good news, but the actual situation is not so ideal. Here, taking the development path of meter-wave radar, which is very similar, as an example, in the early Cold War when radars were widely deployed, the Soviet Union favored the strong anti-jamming capability and long range of meter-wave radar, vigorously developing it and integrating it into surface-to-air missile systems. Because meter-wave radar had low positioning accuracy at that time, the Soviet Union only used it for long-range early warning, while true precise positioning still relied on shortwave radar. This complementary model persisted throughout the Cold War and shone most brilliantly when it shot down the US F-117A in the 1999 Kosovo War. China, eager to address the threat of stealth fighters, later picked up this Soviet concept and ultimately developed it into what is now recognized as the most threatening advanced meter-wave radar against fifth-generation aircraft. Domestically, the advanced label is added specifically to distinguish it from traditional radars, as the two are completely different things now. Current quantum radar is actually in a situation similar to early meter-wave radar. Theoretically, it has great potential, but in practice, it has many problems, such as photons being very sensitive, making it extremely difficult to distinguish clutter from reflected waves. In this case, it does not have the ability to fully replace traditional radars. Utilizing its special properties and cooperating with anti-stealth radars is the most reasonable approach at present. The quantum radar currently produced domestically is likely this kind of auxiliary equipment. Perhaps in a few years, quantum radar may advance further and truly grow into a core device similar to advanced meter-wave radar, but it is certainly not possible now. From the J-20, J-35, to advanced meter-wave radar and quantum radar, and even the J-36, J-50, and the recently emerged large stealth unmanned bomber, domestically, we have unknowingly gone deep on the path of stealth/anti-stealth. Although the US was the pioneer on this path, proposing the entire concept over 40 years ago, it seems to have a sense of development fatigue and gradually falling behind. On the surface, each project individually has its own accidental factors, but when there are many accidents, it is no longer accidental.